Good afternoon, everyone. Welcome to this Advanced Steel webinar, where today we're going to be looking at working with coordinates with Advanced Steel. So as always, a little bit about me before we start. For those of you that don't know me, my name's Rob Merriman. I think I need to update this slide. It's now about 13 years of experience in the construction industry, 8 as an architectural metalwork and structural steelwork draftsman using Advanced Steel. And in those 8 years, I worked in 2 subcontract drawing offices, working on a range of projects, which now means that when I'm doing these sessions with you, I can talk about most things from first-hand experience, having been there and done it. So I currently work as an application engineer for Graitec in the UK, and I work with Advanced Steel, AutoCAD, Revit, Navisworks, Recap, Fusion 360, anything to do with structures. If you guys have any questions, please just reach out to me. So a little bit about Graitec. We are 30 years old, headquartered in France. We are quickly becoming one of the largest Autodesk partners worldwide. We have over 550 staff, and we are technically driven. So out of those 550, 100 are based in our research and development center, producing things like the Power Packs, Advanced Design Connection, Advanced Workshop. And as always, we are here to help you. So whether that's providing training, doing technical support, doing customization, if you've got any questions, please come and speak to us. So our philosophy is that we can take your project from start to finish, and we've broken that down into 4 pillars. So those are create, simulate, fabricate, and manage. So create is using Autodesk products and then enhancing them with the Graitec Power Packs to give you extra functionality. Simulate is taking your BIM model and then checking it can work with in the real world environment. So that's using our software such as Advanced Design or Advanced Design Connection. Fabricate is partly where Advanced Steel sits, but we also have tools such as Armor Plus and Advanced Workshop to manage your workshop and your deliverables. And then all of those pillars and everything to do with your project will produce data and work in progress data. So if you have to work with lots of different common data environments, Graitec's solution for that is called Graitec OpenTree. So you've got one input, which is OpenTree, and then it will work with all your common data environments. So this is a webinar. It is being recorded, so it will end up on our content portal. So every webinar that we do is added there. We do webinars for AC, MFG, and structures. I'm actually going to reference an AC webinar, which is if you're looking at coordinates, could be very useful for you guys. It can take up to 10 working days to upload them. It's usually done within 3 or 4, but as our marketing team, as they get very, very busy, it can take a little bit longer, but it will be up on the content portal. If you are a Graitec customer and Advanced Steel user, talking to you guys based in the UK, if you're a supported and maintained customer, the Power Pack is part of your bundle with Graitec UK. So if you aren't using it or you don't have it installed, please let me know. I can come and install it for you. I can run through the features for you. But the Power Pack we break into 5 key areas, which is create macros. So we have a structure designer that will actually build an entire structure apart from the connections with one dialog. So we can do curved buildings, mezzanines, agricultural buildings, all within the one macro. We then have our own Power Pack connections. So in the 2021 version, we have our own Power Pack connection vault. So we've got 25 of our own connections. Then we have the create elements, so that can be our cellular beams, our folded plate extender, the helical and spiral polylines, and our glass panel creator. Then we have our BIM import and export tools. So if you need to export your model to a DWG, we've got a button that will do that for you. If you're doing high-end architectural metalwork and you need to get your box sections or your tubes laser profiled, then we have a button to create step or IGES files for parts or assemblies. And then with the Power Pack, we also add extra data into the system. So that's the Power Pack. Okay, so what are we going to look at today? We're going to look at coordinates and everything around advanced steel, some of the do's and don'ts, some tips and tricks. So we're going to we're actually going to look at coordinates in the advanced steel environment. Then we'll look at exporting and working with other AutoCAD packages. We'll move on to exporting and working with the Revit environment. And then we'll look at exporting and working with the Navisworks environment. And then finally, I'll give you my general advice. A lot of this is from my experience and dealing with a lot of things on tech support and when I was in industry actually using the tech support. So if anyone does have any comments on anything, please put them in the questions. If you've got other bits of useful information, we're always learning here. So please, there's no right or wrong answer with all of this. Just please let me know in the questions. So coordinates in advanced steel. Advanced steel is built on top of AutoCAD. And in AutoCAD, in theory, your model space is an infinite space. So you could put your building 500 kilometers away in the x-axis and the system would allow you to do that. And each file that you start, each new file has a world coordinate system, so the WCS, and that is a permanently fixed point. And as users, you can manipulate and move the user coordinate system, the UCS, to model what you want, where you want, but that WCS, the world coordinate system, does not move. First advice would be to keep your model as close to the world coordinate system as possible. On tech support and on the forums and things, we see an awful amount of customers' models where things have been modeled 30 kilometers away from zero in the X, 25 kilometers in the Y, and 50 kilometers in the Z. Now, in theory, it all looks fine. But when you move that far away, tens or even hundreds of kilometers, things start to go wrong. And I know this because, like I said, I have been there and I have made these mistakes. So I've seen these mistakes firsthand. Advanced Steel is a 3D modeling program, and the way it works is it works by calculating the volumes of the objects. And when you move a long, long way away from zero, the system struggles to actually do the calculations for those volumes. So when you move a long way away from zero, the following can be affected: your numbering, your clash checks, and your 3D orbiting. This is the one that I had when I was in industry. We'd done some of the train platform extensions that were happening around some of the bigger stations in London. So we actually modeled those platform extensions based off a central point in London, and then the stations would be 100, it wouldn't be 100 kilometers away, but 10 kilometers away, 15 kilometers away. When we went to rotate the model physically started bouncing around the screen. When we went to number, there were two items in the model that we knew were identical, but the system was giving them different numbers. And with the clash checks, we had two beams that were parallel that were they were about 400 millimeters away from each other, but the system was telling me that they were clashing. And when we had a clash, the system got confused and didn't tell me there was a clash. As soon as we put the project back to 000, everything was fine. And a lot of today, not going to be probably one of my longest webinars, probably be half an hour, 40 minutes. A lot of today will be talking about how we can keep our model as close to 000 as possible, but then move it if we need to export to a different package. So I'm just going to bring my advanced steel up to show you as an example. So you've probably all seen this by now. This is our training model. You can see if I click on my UCS tab, the world UCS, and the way I test it is make sure you hit the world UCS and then draw a circle at 0, 0, 0. So you can see my circle is there. So my model is at 0, 0, 0. So ideally, that's where you should put every project. Because we are working in advanced steel, we need our class check and our numbering and all of our drawings and all of our output to be correct. So to a certain extent, I'm not really fussed about the Revit users, the Navisworks users, the Plant 3D users. I need my software that I'm using day in and day out to work best for me. Like I said, if I try and draw a circle, 500 kilometers there, it will let me do it, but when I do a zoom extents, everything gets a lot smaller. And I have seen models that when you do a zoom extents, you can't actually see the model because it's so far out. It's just going to cause you problems, and the only way to fix them is to get that model back to 0, 0, 0. Now, if you have been told that your top of concrete, for example, is 28 meters up in the air, we can use a level marker in advanced steel. Now, I do already have some in here. So we put a level marker in and we go to the global level, and then we can put our datum level in. So the datum level here was 28 meters, 575. That information will pull through to our GA drawings. So when you put a level marker in on your GA drawings, or you label the top of concrete, it will use that information there. Then we can put extra markers in if we need to. So we want to check the top of the steel here. That will tell you that the relative level, so relative to the world coordinate system, is 3 meters. The absolute level, which takes our datum level and adds 3 meters onto it, is 31,575. So that is why the main thing I'm going to keep banging on about today is your model needs to be positioned at 0, 0, 0. Let's have a look at exporting and working with other AutoCAD programs. So when I talk about other AutoCAD programs, I'm talking about sort of vanilla AutoCAD if people are still working in that and they want your model. AutoCAD Architecture, AutoCAD MEP, AutoCAD Electrical, any of the AutoCAD specialized tool sets or Plant 3D, anything that's built on top of the AutoCAD environment, we can use what in AutoCAD is called the base command. Now, what the base command does is it allows users to type their own coordinates relative to the WCS. So in effect, your project coordinates. And then when you insert your model or you XREF it into another AutoCAD platform, it will use the base point. And there is an article in the handout there. So if we have a look at that, so if I type in here base, you can see that I already have some coordinates defined in here. So it doesn't move my model, but the base is set. In fact, what I'll do, I'll override that and I'll set my base back to 0. So you can see in there, we've got a base of 0, 0, 0. If I start a new advanced steel drawing, and this is sometimes why when you work with special parts, they insert in the wrong place, that because the original file could have a base command. We had that on support a couple of weeks ago. If I XREF, I can go and look for a drawing, which I wonder, did I save it? It always helps if you save the file, so let's save that. Try again, otherwise it's not going to work. So I will attach a DWG. That's fine. My computer's on a go slow this afternoon. There we go. So now that's been brought in, that's XREF'd in at 0, 0, 0. So I'm going to unload that. No, I'm not going to detach it. And I'm going to come in here and do the base command. And I'm just going to do 2500. I have found that you have to go the opposite way, which I just found out when I was testing before. So I might have to do a little bit more. Save that again. So my model in here, my original model, I haven't moved anything. But if I now, because I've set the base command, I'm bringing it in at 0, 0, 0. But you'll see that it's now over here. Because when we insert or XREF into another AutoCAD platform, if we have the base, some coordinates set in the base command, it will then do that for us. So if you're working across AutoCAD platforms and you have project coordinates, keep your advanced deal project at 0, 0, 0 and use the base command. This is where I wouldn't say it gets more confusing, but I would imagine that most of your architects and engineers are working in the Revit environment. You still might not get a Revit model, but you will get a DWG of all the plans and the sections and the elevations from the architect or the engineer who's using Revit. And when the engineer creates his DWG of the first floor, second floor, third floor, he can control how that's exported from Revit. Now, this isn't a Revit webinar. We are going to look at it. One of my colleagues has done another webinar on working with coordinates in the AEC collection. So in Revit, you've got 3 coordinate points. You have an internal origin, which is similar to our AutoCAD WCS. That's completely fixed. That you can't even move that. Same as in AutoCAD, you can't move that. You have a project base point, which from speaking with the Revit guys is one that they use internally when they're adding dimensions and things like that. And then you have shared coordinates. So that is usually where they actually identify the point relative to the Earth's surface. So they give it an eastings and a northings. And when you export GA sheets from Revit, the users have the option to use the internal or the shared coordinates when they create their exports. So if you have downloaded a DWG for a project and you open it up, and you notice that the grid lines are a long, long way away from the WCS, the 0, 0, 0, they will have exported that based on the shared coordinates. And I'm going to go through and actually demonstrate that to you in a minute. If they have exported their model using the SMLX file or the Advanced Steel extension for Revit, then that will use the internal origin. So let's go into Revit and have a little look. So this is just the sample project that you get with Revit. Now, if I turn on hidden items, I don't need to save it, thank you. You see we've got this little horizontal arrow and a vertical arrow in here. That is the internal position of the project. That does not move. What people can do in Revit is they can apply eastings and northings to a particular point. And this isn't really a Revit webinar, but in here you can go coordinates and you can specify the coordinates at a point. So they can link a grid intersection, they can link the corner of a building to the eastings and northings, and then when they go to annotate, we can put a spot coordinate, so we could get a spot coordinate there, and it will use those eastings and northings value. Now, it's one thing I am going to put on the Advanced Steel Forums idea page is if we could have this option inside of AutoCAD or Advanced Steel, then it would probably solve all of your export and import problems when it comes to coordinates. But at the moment we don't, which is why I'm doing this webinar. So I'm on a level 1 plan. If I wanted to export that as a DWG, I can go Export, CAD Formats, DWG, and in here, Units and Coordinates, you can see that I can use the shared coordinates or the internal coordinates. So the shared ones are those project coordinates we were talking about. And I have done that. Seems to slow my Revit down when I do it live. So I have, where's my information saved, working with coordinates. I've got the internal coordinates and then the sort of site coordinates. So I'm going to open both of those because it's the same plan view. And this is what I maybe would advise you guys to always do when you get these files, is to actually have a look at where the coordinates are. So if we do the internal, make sure my UCS is set to world, and I will draw a circle, and you can see that that circle is just slightly to the right and the above of this area in here, which if we go back to Revit and I turn everything on, that correlates with that point in there. Back to Advanced Steel, so that's the internal one. And then this is the external one. If I now draw a circle of 1 meter and I do a zoom extents, you can see now this is using these coordinate points in here. So that's the same view exported with 2 different settings. So depending on what they do, so this one is using the coordinates that have been specified for the project. So depending on what has been uploaded for your project and what has been exported, you will get a different outcome. Now, if you want to check how far away from the 0 it is, I can do an ID point, and I can say ID the end point here, and it will tell you in there where it is. Now, if this was me working, I would never work off straight into their file because we need to put this into an Advanced Steel drawing. What I would do is then take this, internal or external, and I would probably do a copy base from a apparent intersection between the grids in here, especially if it's done externally. Internally, we know that that's the center point and that's what's come from their Revit file, so I'd probably leave that there. We're not a million miles away from 0. But for the external one, I would paste that into there because that puts C1 at 0, 0, 0. Maybe we should put A1 at 0, 0, 0. But the point is, we don't want to model a long, long way away from here. Now that's if you've been given just DWGs to work off. If, and I'm sure you guys will have seen this project, which is what I use for when I'm showing steelwork in Revit. I think I showed it the other day. So this is a Revit model created by me in Revit. So all the steelwork here has been done in Revit. If I look at my ground floor and I turn everything on, you'll see that those 2 arrows, the internal point is on grid A1. So that's where I've started this project. Because what I'm going to do here is I'm going to do an export of my frame. I've done it before because it, again, slows me down a little bit. But that will use that internal point. So if I come in here and go export and import, I want to import from Revit. Yeah, I've put this in my desktop, working with coordinates. That will build that whole model for me, but it's using the internal point of the Revit model. So the world UCS, the 0, 0, 0 point of the Revit model. And you can see that column there has come in at my 0, 0, 0 point. So when we're exporting a model through the advanced steel extension, we have no choice. It does it from the internal point. So if I then added extra steelwork and exported it back, it would come in straight away. So if you've only been given a CAD file, try and get them to export it from the internal point. Don't move anything, model straight over the top of it. And if you need to send them the Revit model back to import into Revit, then it will use that internal point and everything will align correctly. And I think this is where a lot of confusion comes in, because different packages work in different ways and they've been exported in different ways, and we've not always been told how it's been done. So the usual thing that we will get asked for is to export and work with Navisworks. So Navisworks is a tool that's available in the AC collection that's used to coordinate models. So if you're working for a main contractor, the main contractor will get your steel model, they might get the cladding model, they might get the MEP model, the electrical model, and they will collaborate them all together in Navisworks, and then they can start running clash checks. But again, that only works if we're all using the same point, or if the BIM coordinators do what they need to do. So when we're exporting to Navisworks, we create what is called a 3D DWF file that uses our WCS, so the World Coordinate System, the point that can't be moved. In Navisworks, your BIM coordinator can move the whole model by typing in new coordinates, which I'm going to show you in a minute. Now, my experience in the past is these BIM coordinators don't necessarily like doing that because they don't know where your model has been modeled from. They will ask you to export it to specific coordinates. If they ask you to do that, don't do it in your original model, because that goes back to my first slide where I said if you have your project millions of millimeters away from zero, everything starts to go wrong. If you move it to do an export, then your numbering can go wrong, clash checks, etc. So I would take a copy of the model, use transform elements to put it where they want it. So let's have a little look at this. So this is the original project. It uses the World UCS, and I would just hit the Export to Navisworks button. This will work if you've got Navisworks installed on your machine. If not, just go File, Export, 3D DWF. It does the same thing. And in Navisworks, that will then open the file, and it will bring that whole model into Navisworks. So when in Navisworks you bring things together, you can actually see the model, and then you can select the beams, etc. But you can select the whole model. And then in Navisworks, you can select a model. You can right click and go Units and Transform. That brought it up on a different screen on mine. It's decided not to do it now. Of course it has. Okay, I'm going to close that down. We'll push the button. Either can't see a dialog box or it's not going to do it now. So let's close it down. And I'll go export to Navisworks. That will export it and then open my Navisworks in the background. Everything is now on a go slow, which is always the way. I just tried to shut a load of stuff down in the background, but I'm going to have to wait, I'm afraid. Okay, so the export has done. My system will eventually open Navisworks, so we'll look at that in a minute. Now, if you're the BIM coordinators or your main contractor is adamant that you have to export it to specific coordinates, this is where I would save my model. I would then do a save as, and I would call this maybe export. And then I would look to use transform elements to do a move, and I would say just select all and move it, say, to 50 meters in the X, 78 meters in the Y, and 30 meters in the Z. But do it in a copy so it doesn't mess your numbering, your class checks, your drawings, everything like that. Because we only want to do this for one export and then run an export. If that figure is a ridiculous number, I had one that was 500 kilometers away from the zero on support the other day. When we did the export, it actually then messed up the export of the beams, and the bolts came out as just really blocky and really horrible. So you do have to be a little bit careful with it. But I would always, if someone's asking me to export to specific coordinates, save a copy and do it in the copy. My Navisworks has come back. If I go units and transform, it's not going to do it. Oh, it is. It's hidden behind my GoToWebinar software. So you can see here, I could say move that 50 meters in the X, 78 meters in the Y, and 30 meters in the Z. I can even rotate it if I need to. And then when we start to look for points in here, that has now moved, because we can go back to units and transform, and it remembers what we've done in there. So if we started IDing points or bringing a different model in, we can do that while keeping our advanced steel model at 000, because it can be done within the Navisworks environment. So to recap and just go through my general advice, always keep your advanced steel models as close to that world coordinate system, the 000, They just need to be there because you don't want your numbering, your class checks, your drawing output to be incorrect. If you receive DWGs where the grids are set to project coordinates and you draw a little circle in the DWG file to check it and they're a long way away, either move your grids to 0, 0 or copy and paste them out of that file into your file but put them at 0, 0, 0. And I would keep a note of the distances that you moved them. And then if you need to move, or if you need to export your project or your model based on those project coordinates, then do a save as and use transform elements. And then the things that you noted down, you can type that value in. One of my colleagues has done a similar sort of webinar looking at how you can collaborate with the AEC collection using coordinates. So very similar from what we've done today. I've obviously just focused it on the advanced steel environment, and I will open it up for any questions. I haven't run any polls today, but do you guys find these issues? When you get given DWGs, are they a long way away from 0? Are you being asked to export your projects to certain coordinates, or are the BIM coordinators doing it? If anyone does have any input or questions, I'll keep this session running maybe till 1:45 to give you guys a chance to type anything in, but that is all the content we're going to be running through today. So a couple of comments. Tim said we rarely get Revit models. True, not many people actually get the models, but if you do get DWG files, they will have been created from a Revit model. So just watch out whether they've been exported from the internal origin or the project coordinates. And then, yeah, Anas is saying we're asked to export the model to Navisworks to federate. So Anas, are you being asked to export it to specific coordinates, or does the person federating them resolve any coordinate issues, or does it come back to you to have to correct your export? Yeah, so Anas is saying it needs to be moved to the project coordinates. Matt's saying he has access to the BIM project, and therefore the models you download are correct in the WCS. We would expect a model as a separate file and align it using the XREF BIM model. Tim's saying in the Netherlands they don't use Navisworks or Revit a lot, mainly IFC files. Again, depending on what software it is, there could be, I can create an IFC file from my Revit model, and again, it all comes back to, am I exporting it based on an internal coordinate or a project coordinate? The one thing I will keep banging on about is your advanced steel model. If you don't want any issues with your clash checks or your numbering and then your drawings, keep it as close to 0, 0, 0 as possible. So Tim's saying IFC and advanced steel don't work great. Tim, Alec has done a webinar on IFC, and and why they won't import in some instances, it's all to do with how the data in that IFC file has been created. You can either create it intelligently or you can create it as dumb solids. And if it's done as dumb solids, at the moment you can't import those dumb solids into Advanced Steel. It will only bring in intelligent objects. When we create an export in Advanced Steel, the system will do everything intelligently with no option, but things like curved beams, there's nothing written in the IFC code to do it intelligently. So the main thing when we're working with all these different platforms is they are all different programs written by different programmers, usually in different program languages. So trying to get one to talk to another without losing any data at all, and intelligent data, is almost impossible. So no more questions. Dave, good question. What distance from the WCS do problems start? I would say anything over a kilometre, maybe even 500 metres, then becomes a problem. It's usually the questions we get on technical support where random things start happening. I will open up a project and first thing I will do is set my UCS to 0. And then I will look at how far it is away from the 0 point. And if it's a long way away, the first thing me, Alec, and John will do is move it to the 0 point, and then we'll test it from there. Because there's nothing that can be done if you've got problems and you're a long way away from 0, there is nothing we can do apart from move it to 0 and then work from there. So that's why I would always put my project at 0, 0, 0. And if you need to export it to any other coordinate, save a copy and then move it. Tim, I don't disagree with you there, but I can't influence how Advanced Steel sees it. We have sent this information to Autodesk asking them to improve the way it sees IFC files. We will have to wait and see for future releases if they do anything with the import of IFC files. It would be good if it could even just import the 3D solids, even if we can't map it to anything, so that we get something in there. Okay, no other questions have come in on the coordinates at the minute, so I will call it a day there. You do have my contact information on the handout. Most of you follow me or are linked with me on LinkedIn anyway, so if anyone does have any questions, just reach out to me and we'll pick them up from there. If you have tech support with us, send it through tech support. Hopefully you found that useful. Like I said, keep your Advanced Steel model at 0, 0, 0, and then you shouldn't have any of these weird problems. And thank you very much for attending today's webinar. I think that is the end of this quarter's bunch of webinars, but we've already got our next ones lined up for February, March and April. So as soon as they are released, we will put it out there and let everyone know about when they're running.